In this video, we're going to talk about logarithmic differentiation by answering the following question. Using logarithmic differentiation, find the derivative of this function, 3x squared minus 2x plus 1 all squared times 2x minus 1 to the 5 all over x to the 5 minus 1 all cubed. This is a very difficult function to find the derivative of using our usual tools of the chain rule, the product rule, the quotient rule, and the power rule. Logarithmic differentiation is going to make finding this derivative a lot easier. Let's talk about the steps we go through when we use logarithmic differentiation. So if we're given a function y equals f of x, the first step is to take the natural log of both sides. So we get ln of y equals ln of f of x. Next, we use the properties of the logarithm on the right side to simplify. Those properties are the ln of a times b equals ln of a plus ln of b, ln of a over b equals ln of a minus ln of b, and finally, ln of a to the b equals b times ln of a. Here we end up with ln of y equals some other expression that we've arrived at by using these properties. The third step is to take the derivative of both sides. The derivative of ln of y is always y prime over y, and on the right side we just take the derivative of whatever expression we found. Finally, we multiply through by y to get an expression for y prime, that is, y times the derivative of our original expression. We can plug in f of x for our function y to get f of x times the derivative of whatever expression we found using step 2. Now let's answer our question. We were asked to find the derivative of this function, so the first step is to take the natural log of both sides. Well, that's easy enough. We just get ln of y equals ln of our original function. Now the second step is to use properties of the logarithm on the right-hand side to simplify. We get ln of y equals ln of our original function, and the first property that we're going to use is the multiplicative property of the logarithm. Inside the ln we have one function times another function divided by a third function. So this becomes ln of one function plus ln of the second function minus ln of the function that was on the bottom. Next, we're going to use the exponential property of the logarithm to pull down all of the exponents inside these expressions. So we get 2 times the logarithm of some function plus 5 times the logarithm of some other function minus 3 times the logarithm of the third function. The third step is to take the derivative of both sides. So as always, on the left side we get y prime over y, and using the chain rule on each of these 3 factors, we end up with this plus this minus this. Carrying out the derivatives on the top, we end up with this expression, which we can simplify slightly to look like this. Now our final step is to multiply through by y. So on the left, we just get y prime, and on the right we get y times our other expression. Plugging in our original function for y, we end up with this huge expression as our final answer to this question.